Let's talk about AI. In particular, I want to talk about some disturbing new developments in terms of the capabilities of AI, of large language models, and their ability to discover exploits or to create exploits, discover vulnerabilities in software. This can be open source software, it can be commercial software. This is software that you have deployed in your environment. And we have to change our mindset. This is really, we need to think of this as a red alert. Uh, LLMs are so good nowadays at discovering vulnerabilities that and creating the exploits, and creating code to actually utilize to take advantage of those vulnerabilities. Is we've got to shift our mindset to an assumption, a default state of every piece of software in our environment has vulnerabilities that can be exploited by a malicious actor. And if we do that, that requires us to really very rapidly shift to a default deny model. If we assume, if we take our minds and we say, okay, in this thought experiment, every piece of software in our environment has vulnerabilities, what that means is we need to immediately have a much clearer picture of what is allowed and expected versus unexpected. And what that tells us is we need to have a clear, well-documented, machine-readable inventory of what's running on our network and what its expected behavior is, so that we can bring down the iron curtain, the castle walls or the gates, and say, okay, for everything that you've told us is expected in terms of inbound and outbound communications from this application, that's great. We're going to allow it for authenticated, properly authenticated and authorized users or identities. Everything that's not is going to be blocked. Number one, that forces some discipline on the organization, which is much needed. It allows you to create automated policies that utilize this machine readable data to be able to very clearly allow what should be allowed and block everything else. It improves the signal to noise ratio as well, so that when you have attempted activity that's blocked, very clearly that's something that needs to be investigated. Is it an anomaly? Is there a malicious actor, a malicious code on the network, or is it simply a mistake that someone forgot to document this use case, or they turned on a new module or trying something else? That becomes a lot easier when you have a much clearer picture of what's allowed versus disallowed, and when it's that network activity is tied to specific identities. So you don't longer have to do this needle in a haystack hunt of, oh, IP address 192.168.5.12 is attempting to contact IP address 10.5.3.7. No one likes doing that. Versus, oh, Sally, who's the chief financial officer in the organization, her machine is attempting to connect to the source code for our engineering team. Well, why is that? That's weird. It was blocked, but Sally's really shouldn't be doing that. So we need to investigate that. Versus, oh, this developer is trying to access this database that is running in our QA environment. It's probably okay. Very different types of scenarios there. The point is that shifting to this default deny mindset by necessity, because we have to assume that all our software has vulnerabilities, gives us incredible power to define automated policies. And that's really what we want to get to, is we want to have these security policies that A, are effective, and B, are automated. And the only way they can be automated is to utilize machine readable data about the identities, about the workloads, and about what traffic is allowed. If you do that, this is going to pay dividends 1,000 times down the road, because now you've got these policies that are enforced, and you have processes, more importantly, so that every time there's an identity lifecycle change or a workload lifecycle change, some workload gets promoted or there's a new update, that machine readable data changes, and your policies will automatically adapt. Get off the treadmill of having to go and manually update policies, or even worse, manually update firewall rules that are associated with IP addresses. So this is something to be aware of, something to be, I would say, a little bit alarmed about in terms of the ease at which AI agents can discover, or LLMs can discover vulnerabilities in our software. But there's a very clear pathway to help defend ourselves against this. Follow the zero trust principles of default deny, explicit allow, and work at increasing the discipline in your organizations for generating machine readable, reliable information around who should have access to what, so that you can then build automated policies that enforce them. Thank you, and stay safe out there.